If you think that because you're using ATP that you are aligning your efforts with infection prevention, you're being misled. I advocate to have ATP monitoring have an adjunct to that, which would be microbiological swabbing or some other method that would help complement and validate your ATP results at minimum.
Millions of patients undergo surgical procedures every single day. They place their lives in the hands of healthcare providers who are committed to delivering safe, functional and sterile instrumentation for every surgery. Working behind the scenes are the technicians who go largely unknown, even to the patients whose lives are so dramatically impacted by their work. This is Beyond Clean, the global voice of sterile processing. Join us as we explore this hidden world and introduce you to the unsung heroes who are driving the advancement of our profession. And now your hosts, Justin Poulin, Michael Matthews, and Hank Balch.
This week on Beyond Clean, we speak with Dr. Greene, Principal Investigator for Sanitation and Contamination Control at NSF International Applied Research Center. Dr. Greene has over 10 years of experience in epidemiological and laboratory research. She holds a PhD in environmental health sciences and an MPH in hospital and molecular epidemiology from the University of Michigan, Ann Arbor. At NSF International, Dr. Greene has been making strides to improve public health in the areas of infectious disease prevention and control in clinical, dental, and community settings. Her work serves to improve the accuracy of environmental-mediated infectious disease transmission modeling, strengthens current guidelines to control healthcare-associated infections, and provides new insight that will stimulate innovative approaches to reduce the risk of biofilm-related infections, pathogen transmission, and curtail the environmental persistence and transmission of infectious agents. Dr. Greene is a co-founder of the Healthcare Infection Transmission Systems, or HITS Consortium, which you'll hear about on today's episode, which is an organization that strives to break down silos in healthcare using a cross-disciplinary systems approach to address the pressing issues around infection control. Mike, this is going to be a good one. And, I will say that Dr. Peter Nickel, who's been on an episode in the past, has talked a lot about breaking down silos in healthcare and that cross-disciplinary systems approach as well. I'd like to see it more in the industry, and I'm really excited to talk to Dr. Greene today, mostly because I know how passionate she is about her field.
Absolutely. And, I'm very interested in information about ATP testing more specifically, because we do kind of treat it as sort of our benchmark for how clean we're getting things not just in our environment, but even our instrumentation. I've done spot checks with ATP of instruments. We've done ATP checks for flexible endoscopes. And so we hold it up there as sort of this model for when we're supposed to focus on instruments more or if we're doing a good job. And so I'd really like to know more about what exactly it is. And I think she's going to give us some really great insight into that.
Yeah, I couldn't agree more, and I'm looking forward to getting into it in just a few minutes. But first, you can subscribe to Beyond Clean on iTunes and Stitcher, Google Play, and Spotify, or search for Beyond Clean on your favorite podcast application. We can also be heard on the Sterile Education app, available on iTunes and Android. Also, we have a number of resources to give away this season, provided to us by Isham, Amy, CBSPD, Rick Schultz, and Pavel de Sternberg-Stoyalovsky. There will be different ways to win every single week as announced on our various social media sites, so make sure to follow Beyond Clean on Twitter at Beyond Clean Info, Facebook.com/Beyond Clean Podcast, LinkedIn.com/company/Beyond Clean, our Instagram page Beyond Clean Podcast. And if you have a question or a future guest for the show that you'd like to recommend, send an email to info@beyondclean.net. Season 3 of Beyond Clean is brought to you by Healthmark and Consortium Surgical. Healthmark has intelligent intelligent solutions for your cleaning verification program, including products to measure water temperature, water quality, cleaning efficiency, and directly test for residual soil left on instruments. Find your tools for cleaning verification at hmark.com. There you will learn about their TOSI and SonoCheck that test the performance of cleaning equipment as recommended in sterilization standards guidelines. And Consortium Surgical, the industry's first group service organization with over 100 years of combined experience. They're unmatched experts in the field of flexible and rigid endoscopy, powered surgical handpieces, medical video imaging devices, and surgical instruments and table attachments set them apart as a leader in perioperative equipment management. Consortia was created with a primary focus on safety, customer satisfaction, quality repairs, and end-user training, providing their clients with measurable results, improvement, and cost savings. Contact them today at consortiasurgical.com or 844-394-8900. We'll be right back after a short break. Beyond Clean. Joining us now is Dr. Christine Greene, Principal Investigator for Sanitation and Contamination Control at NSF International Applied Research Center. Dr. Greene, thank you so much for joining us today.
Wonderful. Thank you. I'm very happy to be here. And you can call me Chris.
Excellent, Chris. Thank you. So we're bringing you on. We're going to talk about ATP testing, and also, obviously, it's in our name, Beyond Clean, but collaborating for clean. It's very crucial to the jobs that we do every single day. And, I thought you could talk a little bit just to kick us off about ATP testing to bring everybody up to speed.
Sure. So ATP testing, that stands for adenosine triphosphate. First, what is ATP? ATP is a macromolecule. It's found in all living cells. And there have been tests that have been developed, particularly I think this originated in the food industry, to use that as a surrogate to monitor or to test if a surface is clean. So ATP bioluminescence testing is a method for once an area has been cleaned, you can go and you swab. There is an enzyme reaction. It uses the enzyme luciferase. Luciferase interacts with the ATP in the cell and then luminesces, or that's where the word bioluminescence comes from. So that light reaction can be measured in the form of relative light units, or RLUs. So the test has become quite popular because it can give a very rapid test result. You get an RLU measurement, so it is a measurement and something that can be used to develop an actual response to. So if that RLU is so high or so low, you know how well that surface has been cleaned.
So the topic of this episode in particular, we're going to go through those ATP tests and perhaps some myths surrounding it, but I want to kind of get us going here at the beginning and say when sterile processing technicians hear disinfection, typically we're thinking immediately high-level disinfection, also sterilization. Obviously, that's the core of our mission in device reprocessing, but in our departments, we're surrounded by working surfaces that also need to be clean and disinfected for us to do our job safely. I'm wondering if you can talk us through some of the primary challenges with surface disinfection in the healthcare setting in general.
With respect to disinfecting the surface, I think one of the biggest issues is understanding the options that are available to you. There are a lot of different chemistries, and by that I mean different cleaning agents, as well as innovations, right? New technologies that are available. And all of them they come with different levels of efficacy, so they will have different abilities to be able to remove the bacteria or the contamination from the surface. And some of them target some organisms and not others. So there are some really difficult ones to remove from a surface. The first one that comes to mind is C. diff. It can exist in the spore form in the environment, very difficult to remove. Not all chemistries can remove that from the environment. And then there are, these other technologies, different types of UV, for example. And where to go to get information about these different chemistries and how well they will work for which situations or purposes that you need is kind of, for the most part, we rely on manufacturers or the sales staff to provide that education. So we do look for publications and articles online, publications such as this, to educate ourselves or to provide that education throughout the healthcare industry. And I think that some of the online white papers, a lot of them are pay to play. So the industry that wants the information to be provided is paying to have the information out there. And so sometimes I think a lot of people don't know what to trust.
Yes, that makes a lot of sense. The topic of white papers and just how reliable they can be is actually something that we've discussed both online and offline on more than one occasion. But I would like to talk to you just real quick about an article that our buddy over here, Hank, wrote interviewing you in Outpatient Surgery Magazine. And he said that you argue that ATP is often misunderstood and misused when it comes to measuring cleaning versus disinfection. So can you kind of elaborate on that and where we've gone off course, when it comes to that ATP testing?
Right. ATP is found in all living cells. So it's in your food, hair, your skin cells. It's in bacteria, not found in all viruses, but the cell has to be broken open in order for that ATP to come out. And so that's the purpose of the ATP releasing agent, to break it out of cells. So there's a couple of issues. Number one, when you use ATP as a method to monitor for contamination, you are also evaluating all other forms of ATP in that reading. So it's not just bacteria. It is bacteria plus everything else. So on the flip side of that reading could be a high reading with no bacteria. It could be a very, very low, seemingly acceptable RLU or ATP reading that's nothing but bacteria. So it could actually be harmful to patients or have a high probability for transmissibility. And what's really interesting, and a lot of people don't understand this, is that the technology or the chemicals that they use in the ATP devices are very similar in nature to the chemicals that we use to clean, those disinfectants. So when you clean a surface and there's a residue left behind, that residue can interact with the chemistry of the ATP method and cause a false positive or a false negative. So depending on the chemistry used to clean the surface, the residue can react with the reaction in your ATP meter and cause the reading to be artificially high or artificially low. So it's unreliable. There's a number of articles that have been published since the 1990s that show that the variability between manufacturers, it's very variable. So there's no standard, there's no benchmark. You cannot use one system or any one system and claim, well, as long as you hit 500 RLUs, that's your benchmark. Above that, it's dirty. Below that, it's clean. So I don't argue that ATP doesn't have a role. It does. Those monitoring systems serve as a really good tool for training purposes, and they do serve as a very good tool for general monitoring of overall cleanliness. Was the work done? It helps to keep housekeeping, they know that they're being monitored, and it keeps them motivated to clean and take care of their job. And to use it for those purposes is great, but to use it as a method for monitoring for contamination. In other words, if you think that because you're using ATP that you are aligning your efforts with infection prevention, you're being misled. So I advocate to have ATP monitoring have an adjunct to that, which would be microbiological swabbing or some other method that would help complement and validate your ATP results at minimum.
So, Chris, you already mentioned one, area where ATP might not give any reading at all, being viruses. Are there other, forms of potential contaminants that will not give off ATP even if they are present?
Gram-negative bacteria tend to you have to break that cell open, and so sometimes that can be difficult for ATP to pick up. Not to say that it won't or that it can't, but that can be difficult.
So in that case, it might actually give you a lower reading when in fact the risk, that doesn't tell you necessarily anything about the risk. Is that correct?
Absolutely correct, yes. You're absolutely right that the ATP has its place, but it should not be used to help estimate risk. That's perfect.
So you mentioned also, you already blew my mind once tonight with informing us that the interaction between the cleaners can cause false and negative results. Is there a specific chemical that people who are utilizing ATP need to look for in order to know that they're at risk for these, false positives or false negatives?
Oh, that's a great question. The best answer I can give you is we don't really know, because each system that's commercially available, they all have their own secret sauce. So, they have different enzymes, or the chemistry to create their ATP system is a little bit different than the next, right? And that's why we have that variability that I just spoke about. And then you have all of these different chemistries. So the combinations between the different chemistries in each one system, you'd have to know that. And that's something I don't know. I don't know if anybody does, because it's how each of the individual systems react with each of the different kinds of chemistries.
I know, Chris, that we're camping out on this chemical question, but it is such an area where there, as you alluded to, there's not a lot of accessible information in one place, definitely, and even more so not influenced by a particular vendor. And that's one of the whole reasons that we created the podcast as well, is to try to get those insights. Yes, everyone has an opinion and perspective, but oftentimes for these frontline users, the only opinion that they're hearing is that sales rep that's in their office, or, this is a product that we've always used, whether or not it's the best or it's the safest, or, all those kinds of discussions have been difficult because we're so siloed in healthcare and in sterile processing in particular. But in regards to this conversation that you mentioned, where do people go and where can they begin to look at these particular surface disinfectants to start that conversation, to begin to educate themselves?
Well, the CDC website has a bit of information. They have also information on monitoring. I think that I happen to like the infection prevention strategy. They have information on a lot of new technology.
So, Chris, one of the reasons Mike asked that question is we had Peggy Spitzer on in a previous interview, and the conversation was about the lack of regulation around cleaning agents. If you say it disinfects, then all of a sudden you're subject to a different level of regulation. But when it comes to just the cleaning agents, I know a lot of the manufacturers, and I know one of the topics was enzymatics with Peggy, but I don't think it has to be an enzymatic cleaner per se, but it could be a detergent. But one of the conversations around that is related to not having that regulation. The manufacturer also doesn't necessarily have to say what chemicals are in that cleaner. A lot of times they'll say it's a proprietary combination of, and so there's some gray area there. So I guess there's also some challenges in regard to the fact that you might not even know what's in your cleaner. Do you see that as an issue that should be addressed in the industry?
I absolutely agree. Yes, I do see that as a problem. I just came back from the ISSA conference, which was held in Dallas, Texas in October. And one of the vendors gave me a free sample. It was a full-size bottle of this household kitchen cleaner. And I thought, oh, this is great. Got home. I went to look at what was in it. It told me zero information about what I was spraying on my kitchen counters. I have no clue if it's colored water or if it's caustic. I find that very troubling. I do know that if a product is going to have any kind of kill claim, that must be EPA registered for that kill claim. So that's a FIFRA registration. And beyond that, there is still a lot of work that we have yet to do. I do believe that the CDC does do a decent job of providing guidelines. So healthcare, they do want a two-step cleaning process where you have to clean followed by disinfecting. One of the problems that I've seen is that there's not a final rinse that occurs with the disinfectants in healthcare facilities. Well, there should be, but it often is a spray and walk away and let it dwell, right, for a dwell time. Then if you're going to go back to that and do an ATP reading of that surface, you will have a lot of residue left behind. Often in the food industry, there's that final rinse. They have to have a final rinse. It's not regulated, and one of the problems with regulation is if you're going to regulate it, you have to be able to monitor it, or you have to be able to make people accountable in some way. So I know for the cleaning process, we still struggle with monitoring that process. But as far as the disinfectants and their use, there is, in my opinion, a lot we can do.
Now, going back to the conversation earlier, Chris, where you blew Mike's mind with the ATP testing and issues, we're sitting over here, okay, we're convinced there's challenges with this. And I think you alluded to briefly microbial sampling. Can you talk about what that is and the potential role that can play in confronting the challenges that we've seen with ATP currently?
Sure. So this is actually something I've been working on with my team at NSF International for almost 2 years now. So the microbial swabbing, these are standard scientific methods that have been around for decades. There's an issue, and because I didn't understand when I first started to investigate why we don't use microbial swabbing, I didn't understand what was the problem, why not? And there's 3 big reasons. Number one, it's generally pretty expensive to do. You have to hire a laboratory that can run the samples for you. That's labor, that's supplies, that's generally too expensive for healthcare. Second reason is traditionally it would take almost a week or about a week to get results. People in healthcare need to know now. Just a sidebar on that, we do need to remove ourselves from the gotta have it now mentality when it comes to patient safety, because ATP plays to that I have to know right now. And not just ATP, there's other methods too, these quick, rapid turnarounds. Those are great, but let's not rely on them as a measure of risk. The third reason, cost, we have turnaround time, and then it's just complicated. So if you are going to swab, how are you going to swab? What do you swab? What's the proper method for analysis? Because the laboratory is going to want you to tell them the method you want them to use usually. And then how are you swabbing for a specific microorganism? The list of questions goes on. So it becomes cumbersome and difficult. And people don't have time to think about this at that level. Most people don't have the kind of education to make those kinds of decisions. So I've worked with a lot of facilities and been really excited about developing a process for them to offer them the opportunity to have their environments monitored using microbiological swabbing. And we've been pretty successful with it, and we've been rolling it out just recently from NSF. We call it STAT-EPID. EPID for epidemiology.
So, Chris, following up on that then, do you think hospitals are properly equipped today and educated to this microbial swabbing process to actually pursue that course in their own facilities?
Most probably not, but I know that I've met a lot of infection preventionists who really are. They're very knowledgeable, but they don't have access to a lab. So at NSF, through our STAT-EPID program, we've rolled out something. This program is nationwide, and we make it really easy for them. We've put our analysis through a production so that we get costs down. We provide them. We're a not-for-profit, so I have no barriers to being able to spend time with whoever needs the counseling and the consultation on the phone to educate them. And sometimes I even go and visit their facility to help them develop a monitoring program that meets their needs. Just as a sidebar, I just wanted to get the word out that if there's anyone who's interested in learning more, just to email me at stat-epid@nsf.org.
And we'll put that information too in the show notes for any who want to follow up, because I agree that's the whole reason that we do this show is to get the information out, number one, but also to start these conversations. And speaking of conversations, you recently had a big conference in Nashville through the Healthcare Infection Transmission Systems Consortium, the HITS Consortium. And I know I'm aware of all the wonderful work that you're doing with that in conjunction with Michael Diamond, but I was wondering if you could speak to what the consortium is for our listeners, and then also if there's any particular insights that came out of the conference in Nashville that you think would be engaging for our audience today.
Absolutely. So this is an organization that I co-founded with Dr. Kelly Reynolds from the University of Arizona. We take a systems approach to addressing infection control issues And by that I mean the whole purpose of this consortium is to bring everyone together from infection prevention, environmental services or housekeeping, facilities management, hospital healthcare workers, and their management, bringing them together from within the facility and then linking those individuals and diverse groups up with research scientists and our industry partners to get the dialogue going about how microorganisms are transmitted in the facility. It's not all hand hygiene, because we could all have our hands 100% clean all the time, but then you can't touch anything around you. Otherwise, your hands will become contaminated. So if we just focus on hand hygiene, we are missing the boat on the rest of how microorganisms move. As a matter of fact, just saw a publication that almost 70% of contamination can be attributed to hands. And this I do ask you to take lightly because it is simulated modeling, which has its own issues. But then we still have this other large proportion of transmission that's occurring through surfaces, water, air, and device. And so we talk about the system and how these microorganisms are moving through the system. And our approach is to tackle infection prevention from where microorganisms are persisting and how they're moving, rather than on the other end of the spectrum, which the CDC, APIC, and other organizations do really, really well at, and that's at the outcome level, CAUTIs, CLABSIs, surgical site infections, and so on. And we are also very research-based, so we have work groups that form at the conferences each year, and then these groups work together throughout the year to tackle the issues that have been brought up to the table at the conference, and then we report back the next year's conference of what we've been doing and the strides we've been making. Some of the great topics that came out of the conference we just came out of in September from Nashville, biofilms and dry biofilms and surfaces. We had Dr. Karen Vickery from Australia come and give a great talk on that. We talked about device reprocessing. There's a lot of issues there, which I'm sure all of you are well aware of. We had a lot of conversations on building design and the ideal patient room. Next year, we will have our expert speaking on airflow in the OR. This year, he spoke on airflow in the patient room. And the list goes on. And I would encourage people to go to our website, which is www.hitsconsortium.org, and to attend our conference coming up in Buffalo. And that would be August 6th, 7th, and 8th. 2019, Buffalo, New York.
Well, at least it won't be cold that time of year. I have many friends in Buffalo. Yeah. So, Chris, this has been a great interview and a great conversation. I think it went by very quickly. You did just talk about where people can go to get more information about the consortium. And I wanted to just also ask, as a clarifier, because we all really encourage people to get involved. And that's one of the biggest things of the podcast. We want to bring information, and then we want to motivate people to learn more, do more, and elevate awareness of the profession. And so I would also want to put it out there that I have a feeling that people can get involved very easily. So do you have to have like some sort of experience to get involved with the consortium? Like what's kind of the structure around who can participate?
Anyone can participate. Our members are come from all over, all kinds of backgrounds. So all over the United States and all kinds of backgrounds. We have infection preventionists. We have a couple of medical doctors. We have a lot of scientists. We have a lot of people from industry who don't have a professional degree, but they've been in this industry for a while, whether it be the water, air, building industry. In fact, we have next year at the conference, we're hoping to have the carpenters union giving the ICRA training, which is the infection control and risk assessment training for carpentry. So when there's building renovations and even new construction, how that impacts and affects the transmission of microorganisms in that building environment. So you could be a carpenter. Whatever your background is, that's not what matters. What matters is that you have a passion and an interest and want to become involved. Our motto is Catalysts for Change, because we are a boots-on-the-ground organization. So we're all volunteers, and if it weren't for the drive and the passion that everyone who's involved has, I wouldn't be as far along, or this organization wouldn't be as, we've developed quite a bit in just 3 years. There's a big need, and people really want their voices heard, and they want to be able to make a difference. They see where the needs are, and our government isn't always able to take care of some of these issues, and part of our job is to bring these issues to them and to communicate up through the chain what needs to be fixed, and not only just say what needs to be done, but propose solutions for how it can be done.
Excellent, Chris. Thank you very much. This was a fantastic interview, and I have a feeling we'll have you back on a future episode. We say it all the time, but
okay.
I'm sure you've got more to say, and I know our listeners are going to enjoy this episode this week.
Thank you very much for having me on. I've really enjoyed speaking with all three of you.
That was Dr. Christine Greene, Principal Investigator for Sanitation and Contamination Control at NSF International Applied Research Center. We talked about ATP testing, and I know we tied in a lot of other or at least one other previous podcast episode, Hank. But one thing we didn't get to talk about, and I'd like you to kind of put her comments in context in your article for Outpatient Surgery Magazine, because I know you were dodging that a little bit, but I'd like for you to kind of maybe tee that up and just give us a little bit of an understanding of what the context of her comments were.
Yeah, sure. And the article in Outpatient was mainly focused on surface disinfection in the healthcare setting, in particular in the perioperative setting. But what struck me about that conversation, I'm always writing and thinking from the sterile processing perspective. And as we spoke at the beginning of this interview, even though we don't have patients in our areas, there are a lot of surfaces, and all of those surfaces should be cleaned and disinfected on a regular basis. So I was struck, just like Mike in this interview, had my mind blown when we're talking about all the challenges related to ATP, all the interactions with chemicals. And I knew after that interview, oh my gosh, we've got to bring this on the podcast to have this conversation and really focus that insight into applying to how we do things here in sterile processing. So this is definitely the beginning of a longer conversation. And if you're like us, you know, you have your mind blown, but then the next question is, okay, so now what do I do? I'm aware of the challenges and the issues, but where do I go next? And that's why I think Dr. Greene did a great job of giving us some other opportunities and directions on how to find out information, where to go, how to collaborate together across specialties. So that's the whole purpose of the podcast, and it was another wonderful show.
Yeah, you know, we've met so many passionate professionals in doing this podcast over the last year and a half, and Christine's right up there at the top with the likes of Peter Nickel. And this episode, as we mentioned before, it made me think about episodes with Peggy Spitzer. I know we referenced that one, but also David Hilliker. And as often happens when we complete the interview, there's an off-air conversation that happens. And, you know, we talk about chemicals specifically in this episode. And so it can't stress enough how important that David Hilliker episode is. And I want to give it another shout out before we close. But that's going to do it for this week's show. As a reminder, you can help support us by subscribing to Beyond Clean on iTunes or Stitcher, and now also on Google Play and Spotify. Simply search for Beyond Clean Podcast. We'd appreciate a rating and a review because your feedback is important to this show. If you have any topics that you'd like us to cover on a future episode, or if you'd like to share a picture anonymously on our Instagram page, just send an email to info@beyondclean.net. On behalf of Hank, Mike, and myself, thank you for listening to another edition of Beyond Clean.